All right, welcome to the Algebra 2 practice final. This is the second version of the practice final. List the first 5 terms of the sequence here. So we know the first term is 5, that's denoted right there. And what are we doing? Well, this notation means whatever happened last, subtract 3. So it's the last term minus 3, the last term minus 3. So I go 2, I subtract 3, I go into the negative world, negative 1, subtract 3. Now I'm down to negative 4. Subtract 3. Now I'm down to negative 7. This business here just means that I have the first term. So this recursive formula starts with the second term, and I just do the last term minus 3, the last term minus 3. This is the explicit formula where you can go to any place you want to in the term. So you can go 1, 2, 3, 4, 5. There's 1, 2, 3, 4, 5 terms I want you to do here. But you could put 5 in here and get the 5th term before you do the other ones. But basically, your growth factor, or your decay factor, is 20%. So you're keeping 80%. So it's going to be 5 times 0.8. So you're going to lose 20%. Right? And then you're going to do 5 times 0.8 twice, so you're going to lose 20% twice. And you're going to do 5.08 3 times, and then 5.08, and you're going to do that 4 times, because it's n minus 1, so the 5th term is actually to the 4th power, because you're losing 1 each time. So we just need to know these 4 answers. Another way you can do this, you just keep multiplying by 0.8 over and over again, which means you're losing the 20%. So we have 5 times by 0.8, that would be the first number, times by 0.8, that would be the next number, times by 0.8 would be the next number. So before I lose track, let me write these down. 4 goes here, 3.2 goes here, 256 goes here, 2.56 goes there, and then the last one would be 2.048. 2.048. Ta-da! I need a drink of water. All right, now we have this double 1 situation here. We have to look at this 2 ways. So the first term, h of 1, so that's the first term. The first term is 3. Then when you go to the second term, it's 6. So if you think about it geometrically, that means it's doubling, so I'll make a note there. And if you go from 3 to 6, arithmetically, we're adding 3. So we need to make 2 explicit formulas, one where we're adding 3. So here's how this works. If your starting is 3, right, that's the plus 3 at the back. So your starting is 3 at the back. You're changing by 3, but you do that n minus 1. And that would be f of n. So you're not adding 3 to the first 3, you're adding 3 to the next term. So you have to have this n minus 1. So does this make sense? If I put 2 in here, 2 minus 1 is 1, and then times the 3 would be 3 plus 3 is 6. So if you have the second term, so I'll write it out here, f of 2 is equal to 3 times 2 minus 1 plus 3. So we know that it's h, it's doggone it, it's h, not f. I'm so used to writing f. H of 2. So if we put 2 in here, so that would be 3 times 1 plus 3. Well, that would be 6. So yeah, when you put 2 into this formula, that's the correct formula. Put 2 into that formula, it will give you 6. Now we're going to put 120 into the formula. So f of 120 would be 3 times 119, because you're not adding 3 120 times, you're adding 3 119 times. So hopefully that kind of makes sense. So now we just need to get an answer for this. So we do 3 times 119 plus 3 equals 360. So 360 would be the answer for that. All right. And so I got 2 answers. So I got the answer and then that. Now we're doing geometrically. We're doubling it every time. So it's kind of the AB to the X situation. You start off with 3, you're doubling, and you do that n minus 1 times. So it's that n minus 1 situation. And then let me write it down. This is h of n, not f, h of n. Now we're going to do the 20th term, which means we're going to raise it to the 19th power. So h of 20 is equal to 3 times 2 to the 19th, because it's n minus 1. You're not multiplying by 2 to get the first term, you're multiplying by 2 to get to the second term. So it's always that n minus 1 situation. So we go 3 times 2 to the power of 19, and it's a significantly large number. It is over 1 million, so it's 1,572,864. All right, so you got that answer, and then you got the equation. All right, now we're doing the steps here. So we got toothpicks. We got 4 toothpicks. So it's 4, and then 7 toothpicks make that, and then it's 10 toothpicks make that, and 13 toothpicks would make that. So it's 1, 2, 3, 4, 5, 6, 7, 8, and then you got 9, 10, 11, 12, 13. So what you're doing is you're adding 3 additional toothpicks every time. So it's the previous term, which is the n minus 1, which is that, the previous term. And then we are adding 3. Oh my gosh, it's the same as this problem, except for it's adding 3 instead of subtracting 3. And then you start always with you're given the first term, and then you start with the second term. So that's a 2 right there. Next page, we are finding x-intercepts. So we set your factors equal to 0 to find x-intercepts. And we do 0 product proper super t. So we get x minus 3 is equal to 0, x plus 4 is equal to 0, and 2x minus 3 is equal to 0. Add the 3 over, x is equal to 3. Subtract the 4 over, x is equal to negative 4. Now this one requires 2 steps. Add 3, right? We're just doing basic solving. 2x is equal to 3. Divide by 2, x is equal to 1.5, or 3/2, if that makes you happy, or 1.5, right? Any of those answers work. The next one here, you're going to do the polynomial long division to completely factor this. Hopefully you have enough room here. So it's x plus 2, make your division sign, x cubed plus 12x squared plus 41x plus 42. We pick it out, we multiply it out, we subtract it out. I'm going to pick up the red pen in between because that's how I subtract. I made everything positives to make it easier on you. So we get x squared. Multiply. Why did we pick x squared? Because it has to match that. So x squared times x makes x cubed. When I subtract it, it goes away. X squared times 2 is 2x squared. Line. Subtract, subtract. Red pen. Okay? This has to disappear, otherwise you've done something wrong. This is now 10x squared plus 41x. All right, pick it out. I need an x, but I also need a 10, so it's 10x. Notice the power drops. 10x times x is 10x squared, and then 20x. Red pen, red pen, red pen, subtract, subtract. So now this is going to be gone. And then 21x plus 42. And then we need to plus 21, because 21 times x is 21x, 42. When you subtract these, you get a remainder of 0. So now we know that x plus 2 times x squared plus 10x plus 21 is the same thing as p of x. But we want linear factors. So I have this one known linear factor, and then I'm going to take the second part here and break it up. So this is the answer right here. This is the answer. I want 3 linear factors. So I do x, and I factor this. 21 is 3 and 7. 3 and 7 make 10 when you add them. Officer Burnett half donut trick, which is what you're going to do here in this one. You're going to factor this. We get x, and then I kind of, with a plus in the back and a minus in the middle, it's always double negative. So it's 8 and 1, and then a double negative there makes it x 0, 0 product proper t. So x minus 8 is equal to 0. X minus 1 is equal to 0. So x is 8. That's one of the x-intercepts, and x is 1. So you add that over, and you get your two answers. Okay, question number 8. Question number 8. We love our binomials, so remember you got to hug your binomials, and then we cross multiply to solve a proportion. So it's 5 times x minus 4 is equal to 7 times x plus 1. Then we distribute. 5 times x is 5x. 5 times the 4 minus 20. 7 times the x is 7x. 7 times the 1 is 7. Then I always say move the smaller amount of x, but you got to get the x's on one side, numbers on the other. So that's smaller, so I'm going to subtract over the 5x. You don't have to. You could move the 7x, but it keeps things positive here, which tends to help. Then we're going to move, so if we move the x this way, so it's an ebb and flow, right? We move the x this way, so we're going to move the number this way. So subtract 7. Subtract 7, that gives me negative 27 is equal to 2x. I'm running out of space, so I'm going to write negative 27 is equal to 2x over here. Divide by 2, and we get a half of 27 is what, 13 and a half? So negative 13 and 1/2 is equal to x, or you could have left it as negative 27 halves as a mixed improper fraction, or negative 13.5. So any of those answers work. Okay, question 10 or 9. This one here, I was like, oh, well, x and x, you got to add. So it's x plus x is 8. So that has to be 4, right? 4 and 4 make 8, so x is 4. When you see square rooting, you have to square each side. So you get x minus 5 is equal to 6, not 16, but 64. 8 times 8, 64. Now we add the 5 over, and we get x is 69. There it is. We're going to solve by factoring. Factoring is an important part of Algebra 2, and you should be able to do it. 60 is 6 and 10, but it's also 5 and 12. So if you have 5 and 12, that will make the 17 in the middle. 0 product proper t. 0 product proper t. So you subtract the 5 over, so you get x is negative 5. You subtract the 12 over, x is negative 12. Now we're doing the quadratic formula. So a is 1. B is 5, and C is 7. So it's 1, 5, 7. Quadratic formula is provided there for you. So we're going to put the B in, which is negative 5. So x is negative 5 plus or minus square root over 2a. 2 times a would just be 2, because a is 2. Now we're doing the part underneath the square root, which I always do in green. So I'm going to get out the green highlighter. This is the part that you put into the calculator, what I highlight in green. Not the square root, just the part underneath. So it's b squared, so I'm going to use baby parentheses, 5 squared minus 4, baby parenthesis, a is 1, baby parenthesis, c, which is 7. All right, x is equal to negative 5 plus or minus square root over 2. So just type that part into your calculator. So you can't go wrong if you use the baby parentheses. Squared minus 4, baby parenthesis, 1, baby parenthesis, 7, baby parenthesis. I'm calling it a baby parenthesis because there's nothing in it except for just a number. Negative 3. That's not too bad. You could have done that one in your head. That's 25, and then minus 28 would be negative 3. When there's a negative number there, that means that the parabola never is equal to 0. It never has a place where it crosses the x-axis. So the solutions are non-real. They're imaginary, right? Complex solutions. So x is equal to negative 5. We take out the negative and we change it to I, because the square root of negative 1 is I. Square root of 3 over 2. All right. Okay, now we go into the exponential stuff. Y is equal to a b to the x. So we say Our starting amount is a $25,000 car, and we're losing money on the car, so that means it's losing 18%. So now it's subtracted from 1, means it's losing 18%. So I've lost 18 pennies off the dollar. So we're going to raise that to the 5th power because of the fact that we're doing this for 5 years. We just type this into the calculator because there's your starting amount, right? There's your change, and then the 5th power is your number of years. So it's equal to 25,000, and then 0.82, and then to the power of 5. Enter. So it's $9,268.50. All right, $9,268.50. Okay, next question. Bay it up. Log. Base. What's the base? The base is what? The base is what? 4 of the answer. 64 is equal to the exponent. Logarithms are the mathematics of exponents. So this is the base, right? Logarithms are base, and there's your answer, and there's your exponent. That's how you write it out. All right. Solving to 3 decimal places. So we're going to use a log, and we're going to type it in the calculator. So the first thing is we need to isolate this. So I'm going to add the 12 over. I'll go back to purple. Add the 12 over, which means I have 92. So I have 2 to the x power is equal to 92. And now I bay it up. Log base 2 of answer 92 is equal to x. That's the exact answer. Now it's been a while since we've done this. If you go to the math, and you math button here, whoops, the math button's right there, and you go down, you have a log base button, which is A. You put 2 in there, and then you put 92 in there. Enter. So I went 3 decimal places. X is approximately equal to 6.524. Right? 6.524 when you put it in. Log base 2 of 92. So you've given me 3 decimal places and the exact answer. Okay, number 16. Number 16 is about E. E is when you grow things that are natural, like people or bacteria, populations of things like that. All right, so you can see right there the starting amount is in the front just like before, but it says it's in thousands. So how many bacteria are there? There's 2,000 bacteria. This doesn't have 1 with it because it's a different model. It's just the growth rate's just 5%. So you don't have to have 1.05 like the other exponential growth model. It just tells you 5%. Okay, how long will it take to reach 10,000? So here's what's tricky about this is you have to keep it in the same ratio. So I'm going to cross these out and say 10, which means 10,000. So we say 2e to the 0.05t is equal to 10. So 2,000 is becoming 10,000. 2,000 is becoming 10,000. So I had to kill those zeros right there. Divide by 2, divide by 2. This tells me that it's 5 times more because 10 divided by 2 is 5. It went up by 5 times the population. Now we bay it up. Except for I don't do log, I use natural log because natural log is base E of 5 is equal to 0.05t. That's multiplication, so then I divide by 0.05. So t is approximately, this is the exact answer. Type this into your calculator. Natural log 5, close your parentheses, divided by 0.05, and 32 years. So 32.189 years. No, it's not years, it's the number of days. My bad. Population are growing fast. It's days. All right. Okay, this is the from the Unit 5 test. So do I know a y value? Yes. Drink of water. 0, a, x. X is 0 minus h, 2 squared, k, 5. So there's your h and the k, and there's that. So if you know a point, and I'm giving you 0, 0, that's an easy point, and the vertex, you can write the equation. So you're finding the multiplying factors. That's what this question's about. It's like, what's multiplying factor? Flips it upside down and then squishes it in. It's going to be some negative fraction. So here we go. There's multiplication in them thar hills, so you have to honor the multiplication. So 0 minus 2 is minus 2. You square that, so negative 2 squared is 4. So instead of writing a4, I'm going to write 4a plus 5. Okay, now I got to solve for a. That's an a. So subtract the 5 over. You get negative 5 is equal to 4a. Divide by 4. So it's negative 4/5. So here's the equation. Y is equal to negative 5/4 x minus h. H is 2 squared plus k, which is 5. Okay, so this should do it. So you can test this on the calculator to make sure that you did it right. So let's do that. Negative 5 divided by 4, left parentheses, x minus 2 parentheses squared plus 5. All right, now we're going to hit the graph button. Boom. That looks like the graph, doesn't it? Hit the trace key, 0, 0. Hit 2. Yep, it goes through 2, 5. It also goes through 4, 0. So if I hit 4, it'll tell me 0. So it works. All right, so this is 2, right? This is just the equation 2. So if you add these two equations together, you're just taking the f equation, you're adding 2 to it, which means it's going to move it up 2 spaces. So you just go up 2 spaces, going back to purple. So 1, 2. And then it's just going to do what the other one did. It's just going to be 2 spaces higher. So this is just the constant 2. If you add it to the equation, it's just going to move it up 2. That's pretty simple. All right, now we get to describe the things. All right, so this is two things. So if you have it in there, you got to think opposite. So it's left 2, and then down 3. This one here, when you put a negative in front of the equation, so what's that do? Negative in front changes the output. So it flips it over, changes the y's, right? So it flips it over the x-axis. Then this one, don't you establish, this does the opposite because it changes the x's. If it changes the x's, x and negative x flip left and right. So it's going to flip it over the y-axis. All right, and the last question, ta-da! Even y-axis. So negative 5 and 5 change, but the x, or those change, the x's change, but the y doesn't. So the y values stay the same, but the x's changes from positive to negative. So that means this is negative 2. Odd flips around from the different quadrants. So that means if this changes, then this also has to change. So this is one's going to be 2. And that makes it odd. Okay, so let's think about that for a second. That's the harder one to think about. So negative 5, or 5, negative 2, 1, 2, 3, 4, 5, negative 2, 1, 2 would be right here. If you're going to rotate it around 180 degrees, it's going to be 1, 2, 3, 4, 5, and then it's going to be up 2. So it goes zoop, zoop, and that means that it's at negative 5, comma 2. Right, and this one is at negative 5, or positive 5, negative 2. And that's the odd situation. So it's zoop, 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 zoop. So it rotates it 180 about the origin. All right, so there it is. It's a long, long way to temporary, but my heart's right there. All right, bye-bye.